All right, so what we are going to be looking at today is finishing off some of the tool pathing that we created a couple weeks ago on this VW Beetle. The last session was on 3+2 machining. We are also going to be looking at 3+2 machining today as well. The difference of what we're doing today versus a couple weeks ago is a couple weeks ago it was only on the work planes that already exist and not off on different angles. So we're going to learn how to put in a work plane like this and then constrain tool paths to only get within a certain area. So before we jump into learning that, I'm going to come over here and look at what we did 2 weeks ago and kind of refresh. We started in the design process on the design window. We sketched out a box on a sketch, and that is a construction sketch. And that was just used so we could scale the 3D model down and just kind of get it to fit within a size that we expect it to be. When we brought this model in, I think it was like full scale. So we shrunk it down using the modify. Under modify, there was move and scale, kind of stretched that down to fit. We then moved it into a position of closer to XY0. Not that we have to do that. It's just nice to have it in an orientation of closer to 0 for when you're painting and moving around and rotating. Then once this was brought in, we sized and moved to the correct location, we jumped over into the manufacturing aspect of Fusion. And this is where we added the setup. The setup is the material that we're going to be cutting on, the stock size. We're able to change a few things. The stock is primarily what you're going to be working with in the setup. Then we went in and created a couple different tool paths for this. We did a top-down pocketing roughing toolpath, which basically just roughed the rough cut out. Looks like we did the same thing for the side. And then we did a parallel finishing. And I could see that finishing right now probably didn't give us the smoothest cut, because I'm kind of able to see the spacing of these lines is what's going to give us the resolution. So these blue lines are where the center of the cutter is going to follow. We do have the simulate under the right click and then simulate, and go ahead and hit play. And we'll see what this looks like when it is done. Let's see if we can still see it with it turned off. No. So you can kind of see it a little bit that we're getting gouge marks, and it's just not very smooth. And that is done within the step over of the tool path. So the tighter these lines are together, the smoother the finish and the overall finish is going to be. Typically, you want to make that 10%, 8 to 10% of the diameter of the cutter. So to change that, we're going to just double click in the parallel finishing to open up our settings here. And we have the passes. And it is the step over right here. So we're cutting with a 1/8 inch cutter. So it's only stepping over, like 50% of the cutter. So want to get a much smoother finish. We'll go 10 thousandths. And we'll say okay to that. It's going to take a little bit longer to calculate. And it also, by putting that closer together, it's going to take longer to cut, just because there's going to be a lot more miles that the machine is going to have to travel to get a smoother finish. So there's a trade-off between how long it takes to cut versus how long you might do some handwork on it. So now we can see that those blue lines are, very tight together, and that is going to provide a much smoother, cleaner look on the toolpath. So let's see if we could simulate this over. There's probably a way through one of these visual settings to hide the actual toolpath lines, but a couple of things that I want to point out that we're seeing it is much smoother across the face over here, but as it came up across the side, we have a lot of steps created here. Those steps, they're only 10,000ths of an inch between this step and that step. So, a quick sand would probably get that, take care of that pretty easily. But the reason that we're getting these steps up here and not across the face here is we are using an end mill, not a ball nose. So we're getting like a stair step effect as it travels up the side of a vertical wall. If we used a ball nose, we would get a smoother finish across the vertical walls here. We might possibly get more of a scallop across the horizontal roof in the face of the windshield. The reason for that is the end mill is using more of the leading edge of the cutter rather than the ball nose just using the very tip of the cutter. So depending on what type of orientation you're rastering in is going to get a smoother finish than the other. So for example, you're going forward and backwards across the side of the vehicle. If we were traveling from driver's side to passenger side and back, we would get a much smoother edge, not stair-stepped along the vertical walls on the sides of the vehicle, but coming up the windshield, we would get those vertical stair-stepped type of lines. So don't always think that a ball nose is the best option. Sometimes a end mill works very well for creating a tool path on an angle, especially since we have the ability to change the approach plane of the cutter. What we're going to take a look at is how to create a plane across the front windshield and also create a 3D tool path on that angle if we used a end mill that's keeping the flatter surface of the model in the same orientation that an end mill might be. So I'm going to exit the simulation, and to create a work plane, there's several ways of doing it. The way I go about doing it is going to the design. And right now we don't have any of the views turned on. So this is the X, Y, and Z planes that are showing up. Right there. And what we want to do is create another plane that is off on an angle to one of these ones. And we are able to do that by going into the construction and then plane at angle. It's wanting us to select an axis or a line to create a plane on the angle at. So if we select this Y axis here it gives us a plane, and then we could use the rotate here to view that. I'm going to click on front, and I'm going to just kind of rotating this around to somewhat match the angle that we have on the front of the windshield. Or if we wanted to do it across the backside, setting it on that angle there for the backside. And we might go ahead and do both. Yeah. All right, sorry about that. Put this on pause for just a second. I forgot to turn volumes down. All right, so now that we have this plane on the angle of that's somewhat matching the windshield here, I'm going to go ahead, okay. I'm going to just make a mental note that it's also at 55-degree angle. And we'll say okay to that. Now what that has given us is a work plane that we're able to use to create a sketch on top of. So to create a sketch, I'm going to select that plane. You don't have to select the plane first. Two ways of doing it. I usually select the plane first, then come up to create the sketch. And it just kind of rotated that around to where the sketch is the horizontal plane now, and rotated that around. And this is the orientation that we are going to align the z-axis to. So we were able to cut essentially straight down on it as if we rotated the model itself on the machine. So you'd be able to do a very similar thing on a 3-axis machine, where instead of just reorienting the work planes as we're doing, it is the same as re-indexing, taking the material off and rotating the model on the 3-axis machine and doing it again in 3-axis motion. So I do want to create a toolpath to only cover the windshield section. And to do that, with that sketch activated, I'm going to come up to sketch out a 2-point rectangle. And for the line type, I'm going to set that to be a construction line, and just come in and sketch out a rectangle based on the size of the windshield. And basically that is going to become the containment rectangle for the toolpath that we're going to create. So that rectangle is created down below on that work plane that we have just created. And that is found under the construction options here. And we could see that there. That is the rectangle that we just drew that is matching up to the size of that windshield, or roughly that size. So once that is done, I always like to come up, file, save, just in case something goes wrong. So back into design, manufacturing. And we're able to now select that work plane to create got a mouse button that is stuck. Sorry for that. To use to set the angle of the Z to the work plane. So we're going to go ahead and create a 3D parallel finishing. This is the same one that we just modified the finishing for and created that step over closer together. The first thing is going ahead and selecting the tool, which is already a tool selected there. That's the one that is in the tool database from a previous job. When we come in here, I mentioned it in the last video, and I'm certain I mentioned it in the first one as well, the overall length. That is a critical real number that you're going to have to get off of and from the 5-axis machine by running the routine that is called get tool length. And then need to enter in that overall length here. That is what tells the machine how far X and Y need to be offset based on the angle of the Z to still know where the end of that tip is in relation to the model itself. So with that selected, you could come through and set up your feeds and speeds. That is really nothing different than you would have on your 3-axis machine. So kind of run the same speeds that you would on a 3-axis machine. Our next step is to go to the geometry. And we have a machining boundary. Right now it's set to silhouette. And we are going to do based on selection. The selection that we're going to go is that rectangle that we selected. And notice how it projected a green square off of that. And the reason for that being offset and looks like it's much smaller in the X than what we have sketched, that is because the Z is still seeing it from the top down. So that is the width of what it would machine if we're machining from the top side down, but we do need to change the tool orientation to match the work plane that we created. And that is found under tool orientation. And there are a couple ways of doing this. One, right when we clicked on that, we have this option here to rotate this around, and notice how that green line also is coming up and matching up to the line that we rotated. And remember when I mentioned about making note of that tilt angle or that angle, and that's matching 55 degrees. So we could have just come in here and put 55 degrees and not necessarily drew that angle or that work plane. We could do that, or since we have that plane, I know that sketch is on that plane and on that angle, we could just come in here and select the work plane, and then we could see that it automatically aligns itself to that plane, which is an angle of 55 degrees. Even though it says 0 here, that's because we have it setting to the plane rather than rotating it around. And again, the arrow of the axis of the Z-axis is pointing in the direction that the Z would be approaching from. It's not the direction that the Z is moving. So the Z is coming from the top to the bottom. There is the option here to flip the axes around, which in this case could result in a possible crash because the Z would rotate around, tip up the A axis and orient the B axis accordingly. And if your model is not elevated up off of the table enough, the head could come down and crash into the table surface. So pay attention to where that arrow is pointing. It is pointing to the direction that the Z is coming from. We can now see that that green arrow or rectangle has gotten a little bit bigger for us to use, finish out the tool pathing for it. So the heights is the other thing that we want to come in and do. So right now, this is the area, this blue line is where it's going to completely cut down through and try to get to. In the relationship of where we drew this rectangle, it can't get there anyway because the windshield and the rest of the model is going to prevent it from going down there. So just going to go ahead and click OK. We'll come back into this, but click OK just so we can see what's going to happen here. So it still only did the windshield. And the reason why it did not go completely down to that blue cutting length is because of the way that we drew that boundary rectangle in. We did not go wider than the model. Now, if this rectangle on the back side was much wider, then it would try to come down through the sides all the way down to that cutting plane. So even though we are contained within that rectangle, it is still a good idea to set that cutting plane to a set height, just in case later on you modify that sketch and it does come out farther, and it's an opportunity to mess up and cut too deep and have a collision with the collet as it's trying to get down there. So we will do that by double clicking on the tool path here, opens up the same parameters that we were just using, and coming to the heights, and I'm going to view it from the front. which is really the side of the vehicle. And we could bring this cutting plane up to an area that is not going to have any possible collision, just in case we messed up and reoriented that cutting plane. Come over and also look at our passes, and that is our step over. I'm going to go ahead and reduce that back to 10 thousandths. With all of that done, we will say okay. So that gives us a much smoother finish across the top of that windshield. And even though we are using an end mill, with the orientation that we are cutting, where the majority of the windshield is going to be flat and in line with that bit, that is going to give us most likely a smoother finish than if we were using a ball end mill. So even with a 1/4 inch big diameter cutter, we will still be able to get this model very smooth in this orientation. Now, the bigger the diameter, the less detail we might be picking up, but the smoothness is going to be there. Take another look at maybe getting up underneath the wheel well a little bit. So we're going to jump over into the design and just see what kind of undercuts, if any, we have that we might be able to. It's not looking like we have too many undercuts, other than we could set something up to come up underneath the mirror here a little bit. And that is going to be done pretty much exactly the same way, creating a different work plane. And yeah, so that is under the construction, creating a work plane at an angle. And I'm going to go ahead and select and again, rotate around. This time I am looking at an angle that the approach is going to be from the bottom up underneath. So setting this to an angle, understanding that the YZ or the A is going to have to rotate up into this direction, and making sure that we don't rotate up too much. Otherwise, we will have a collision. So setting something like this could rotate, I think, around 60 degrees. We should be okay with that. And that is, yeah, we're good there. So once we're done with that, I'm going to say okay. And drawing a sketch on that plane to contain the 3D model only around the mirror. And again, we'll use that by creating a sketch. The first time I showed selecting the plane first. This time we're going to say selecting the sketch. And now it's going to say, what plane do you want to sketch on? So we're going to select this backside here. We can see how that rotated around. And again, just drawing in a rectangle with a construction option set. And we'll sketch out a rectangle for there. And I could see we could probably even get somewhat underneath of this door handle as well. So let's put another rectangle right there. Both of those set to construction options. We'll go ahead and finish that and then jump over into the manufacturing. And it is the same process again. So we're going to go to the 3D parallel finishing. The tool is still selected. The geometry, we want to do the selection. And I held the shift key down to select both of those objects that we drew, rectangles. One's for the mirror, the other is for the handle. Then our tool orientation. the construction plane has been turned off. So let's go back into the design and turn that plane on. "3D parallel finishing." Again, tool is selected. The geometry is going to be the selection. And then the tool orientation is going to be this backside. And now we see the arrow on that Z is coming from this direction down. That is not the direction we want it to be. We want it to come from down below up underneath. So we're going to flip the Z axis around. And this is going to create some undercuts. So the Z axis and the cutter is going to be pointing up in the air just a little bit, which means that you have to set the model up higher on a pedestal to allow room for the machine head to get below the model to allow it to point up. How high that pedestal needs to sit all depends on the overall length of the cutter. The longer the tool length, the farther down the Z will have to move to be able to get up underneath of that area. So with that set, again, coming into the heights, this time the height is, off to the right side. So selecting that is going to move that down above where that mirror is, coming over to the passes and changing the step over from 06 to 01, and then select calculate. So that gives us kind of a demonstration or a view of how that cutter is going to make an approach in at cutting and being able to make an undercut into a section. But again, when you're doing this or all 5-axis motion of any approach angle, you have to pay attention to what else is in the way of the head while cutting. So again, we could go ahead and generate a simulation of this, and so there was a collision that just happened. You saw that collet go red. And that is a collision in one of the parallel finishing that we had, that we didn't clear enough material out somewhere, or we did not run the cut depth to the right depth. There is the angle of across the front of the windshield. And then the undercutting from under the so we're going to take a look at what caused that collision. That seemed to be in this parallel finishing. It was somewhere around in this area here. So it was definitely this tool path that I think I saw the issue in. Nope, got to close the exit the simulation first. So I have all of the tool paths turned off, and there's like a little eyeball here that we could flip on, which is should be presenting us with the toolpath. And the collision probably came a little bit from hitting right in here, this depth. Getting down this far, the edge of the collet was probably hitting on the backside of the top or the backside side of the windshield here. So we would have to double click in the finishing toolpath here, coming into the heights and adjusting that bottom height up just a little bit. So again, when the bit would come down to this height right here, the collet nut is probably hitting right around in that area. So we're just going to change that, bump that up just a little bit. And it's snapping in 1/2 inch increments. So we could come in here and enter in 0.25, moves that up, and then say okay to that. So that is generally it is the basics to 3-axis machining. So this is the machine that we're doing is really no different than a 3-axis move that you would do on the 3-axis machine. The only difference here is we are first positioning the A and the B axis, the wrist and the knuckle, to a set angle. Then we are doing 3-axis motion over top of that. So that is the reason that we are using 3-axis machining versus the multi-axis machining. So I think that's kind of what I had to talk about today. I know it's a little shorter than what we've had previously. So definitely have room for questions.
Let's see. Hey, Ryan, can you hear me?
I can.
Okay. I noticed that we always use the rectangle when you're drawing the sketch for the plane. And is it best to just stick to that, or can you use like a more, is there any way to use like a curved plane?
Yes, you could do a curved plane just the same way.
Okay.
I was just drawing out a rectangle just because it's quick and easy.
Yeah.
But yes, if you wanted to completely outline the edges and contain it based on a curve or based on, an unusual shape of whatever, you could do, yes, absolutely. To the machine and to the tool pathing, a straight line really is no different than a curved line. It's going
Right.
to all behave exactly the same way.
Cool. Yeah, I think you probably have to pay more attention even to the collision possibilities, I would imagine, if you go too far on your curve. But yeah, anyway, that was my only question so far.
Yeah.
All right, thanks.
Uh-huh.
Let's see. I don't think- I think the rest, I'm just gonna have to try and practice.
Yeah.
Yeah, and maybe the others can chime in and we can maybe all review all this and play around with the machine before we have another session.
Yeah, that would be good. If you could, get some time on the machine, then that'll give you a little bit of experience to know what you don't know.
Exactly,
Yeah.
exactly. And I know it's a lot. It's
I
been,
will review the first 2 videos. Sorry, I wasn't able to make it to those.
No, that is all right. I'm glad we recorded them.
yeah. Yeah, we did receive those links you sent today, so I sent them on, and Michael's gonna add that to LinkedIn as well as your YouTube links and stuff. So
All right,
hopefully
great.
they'll be accessible for everyone.
I will do the same with this one. And so for the next one, let me figure out where my stop recording is.